Arcs and chords. So our first theorem involving arcs and chords say that in the same circle, or in congruent circles, congruent arcs, so this arc here is congruent to this arc here, they both measure 82.13 degrees, those will have congruent chords. So in other words, this chord here is congruent to that one because they cut congruent arcs. Okay, our next theorem says that a diameter, so it has to be a diameter, it has to go through the center of the circle, a diameter that is perpendicular to a chord bisects the chord and it bisects the arc. Okay, our next theorem says in the same circle, or in congruent circles, chords that are equally distant from the center, so in other words, this chord right here is the same distance from the center that this chord here is. They're both 2.4 units away. Well, they are congruent. In other words, this chord here, this whole thing is congruent to that whole thing if their distances are the same. And that's it for this unit. So let's do some examples. So let's say we're given this picture and we're told that the radius of this circle is 13. Well, guess what? This is also a radius, so it's also 13. And hey, look at this. This is a right triangle. Its side is 5, so hopefully that rings some bells. This is a Pythagorean triple, a 5, 12, 13. Now, since this is a diameter and it's perpendicular to this chord, that means that x and y are the same because it bisects that chord. So y is also 12. Okay, let's look at this one. So it looks to me like we have our old friend, the 30, 60, 90 triangle. Okay, so the hypotenuse is 6, which means that the short leg, which is opposite the 30-degree angle, is going to be half the hypotenuse, which is 3, so we just found y, and the long leg is the short leg times root 3. So x is 3 times the square root of 3. All right, what's the measure of arc AB? So here's arc AB right here, right? Well, it is equal to the central angle, which in this case is 60. Whoop, I'm sorry. Arc AB is this whole thing, right? So this bit is 60. Since this is a diameter perpendicular to this chord, that means that piece is congruent to that, and this arc is congruent to that arc. So the whole AB arc is twice 60, which is 120. Okay, let's take a look at this. So here I've got a piece of a diameter. If I continue this out, it would be a diameter that is perpendicular to this chord, which means that it bisects the chord. So that means x is 8. Now you'll notice that this distance right here to that chord is equal to this distance right there to that chord. So since they are the same distance away from the center, that means this whole thing is congruent to this whole thing. So this whole thing is 8 plus 8, which is 16. So that means y is 16. And here's our last example. We have a circle of radius 17 and it has a chord of length 16. How far from the center of the circle is the chord? So let's locate the center. Let's say it's right there. And here's my chord. That's 16. And there's my radius, 17. And to get this distance right here, which I'll call x, that's going to bisect that chord because it's perpendicular. And that means this is going to be 8. Hey, I see another Pythagorean triple. 8, 15, 17. So the distance is 15. All right, that's all you have to know for arcs and chords.